Okay, so we're now moving on to collecting like terms, and we saw previously on the last video that, well, if we have 5 plus 5 plus 5, we could write this as 3 lots of 5. They mean the same thing. And similarly, if we had b plus b plus b, now just using a variable, okay, we can similarly write this as 3 lots of b. And this is going to be a very useful idea for collecting like terms. So this here is an example of collecting like terms, okay, because you've got b plus b plus b, they're all the same variable, okay, so you can combine it together. So like terms are terms that feature the same variable. So you can see here we're using b in each of these here. Now, if we have this, simplify 3b, add 4b, well, we've just seen up here that 3b, okay, if you wanted to write out in long terms, is the same thing as b plus b plus b, which is down here. If I'm going to add on now 4 more b's, okay, literally I'm adding on 1, 2, 3, 4 b's, okay, and we can see that in total you've now got 1, 2, 3, 4, 5, 6, 7 b's. Okay, so this really is kind of showing you behind the scenes of what goes on when you add 3b, add 4b. But all you're doing, because you've got the same variable, they are like terms, okay, well 3 add 4 is 7, and you just put the b on the end because they are like terms. 3b add 4b is 7b, and this is showing you why that is the case. Okay, so let's look at simplifying some expressions. So the first one, we've got a plus a plus a plus a. Well, this one, okay, you've literally got 1, 2, 3, 4. You've got 4a, so it's just going to be 4a, and that is it. Okay, and let's highlight the answers as we go. So 4a is the first one. Question 2 is simplify x plus x plus x, take away x. Well, first of all, x plus x plus x, looking at the first 3 parts, okay, looking at the first 3, is going to be, well, 3x. Okay, you've literally got 3 x's. Now, if you're taking away x, okay, that means taking away 1x. So take away 1x, or 3x take away 1x is going to be equal to 2x, okay? Important to mention, actually, that you don't see it, but here this means x means 1x, add 1x, add 1x is 3x, take away 1x. If there's no number before the variable, there's a 1 there, okay? That's important. Question 3. This one we've got 3m plus m, and again that means plus 1m. Well, to write it out in long, if you wanted to, well, 3m, it means m plus m plus m. That's the first part. If you're adding on another m, you can see you've got 4 m's. So 3m plus m is going to give you 4m, because we know that 3 add 1 is 4. Okay, so that is your answer for the third one. So 2x and then 4m. Question 4. So now we can hopefully see, well, we'll go through this one. We've got 6w take away 4w. And maybe you're just thinking, okay, well, now we can just do 6 take away 4, which is 2, and it's like terms. You've got a w and a w. It's going to be 2w, and that is absolutely correct. To show you the reason why, well, 6w means you've got w plus w, 6 times 1, 2, 3, 4, 5, and then 6. If you're taking away, if you're removing 4 of them, well, you're taking away 1, 2, 3, 4. You can clearly see you've got 2 w's left. Okay, 1, 2. But again, if you've got the same variable, which we do, you can just look at the number part. 6 take away 4 is 2w, and that is it. Good. Question 5, we've got y take away 3y. And again, this means you've got 1y take away 3y. Well, 1 take away 3 is equal to negative 2. Okay, so it's going to be negative 2. And you've got the same variable, you've got a y and a y. Negative 2y is your answer for that one. Okay, so let's highlight that, negative 2y. Question 6, this one, the variable this time is x squared. You've got x squared, add x squared, add x squared. But importantly, these are all like terms because they're all x squared. Okay, and you can see you've got, well, 1x squared, add 1x squared, add 1x squared is equal to 3 lots of x squared. Okay, so that is your answer for this one. Let's give that a highlight. Question 7, we've got 3ab plus 7ab. Again, importantly, right, your variables are the same. You've got ab and you've got ab. So these are like terms, which means you can combine them. So 3 and 7 is going to give you 10, and the variable here is ab. So 10ab is your answer. Okay, again, if you wanted to, you could look at this by saying, well, the first part of 3ab is you've literally got ab added to itself 1, 2, 3 times, and you're adding on another 7, so you're adding on another 1, 2, 3, 4, 5, 6, and then 7. And you can see if you count them all up, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lots of AB. So that is what is going on behind the scenes. There we go. Question 8, we've got 9b squared take away 3b squared. Well, again, you've got the same variable. You've got a b squared and a b squared, which means they're like terms. So you can just go and do 9 take away 3, which is 6. It's going to be 6b squared. And that is your answer for question 8. Okay, so there you go. You can try your turns. You can pause the video, give those a go. You can, of course, refer to the my turns, and I will go through these now. So you can fast forward to the end and check out your answers. Question 1, we've got c plus c plus c, which will give you 3 lots of c. That is your first answer. Question number 2, we've got b plus b. Okay, so b add b is 2b. You're then taking away b and taking away another b. So really here you're doing 2b and you're taking away another 2b's. Well, 2b take away 2b is actually going to give you 0. Okay, if you've got 2b, b add b, that is 2b, and you're taking away both of them, well, they go. There's nothing there, is there? Equal to 0. Okay, so equal to 0. That's a bit of an awkward one, but it is equal to 0. Question number 3, we've got d add 4d. So what's 1d add 4d? Well, 1 add 4 is 5, and you've got the d there, so 5d. That is your answer. Question number 4, we've got 10a take away 9a. Well, 10, it's the same variable, which is important as with all of these, but we've got 10 take away 9 is going to give you 1, and your variable is a, 1a. But we write, in algebra, if you've got 1 something, you just write it as that letter. So a is simply your answer there, a. Good. Question 5, we've got 5x take away 7x. Well, 5 take away 7, it is not 2, it's negative 2. Okay, if you need to, number line, you're at 5. If you're taking away 7, you're going back by 1, 2, 3, 4, 5, 6, 7. So 4, 3, 2, 1, 0, negative 1, negative 2. So negative 2x. Okay, never be afraid if you need to use that number line. Good. Negative 2x. Question 5, we've got k cubed, add k cubed, add k cubed. Importantly here, you've got the same variable. You've got a k cubed, and a k cubed, which means you can just go and say, well, you've got 3 of them, so it's going to be 3k and then cubed. Good. Question 7, we've got 10xy, add 12xy. Again, you've got the same variable. You've got xy, you've got xy, so you can do 10 to 12, which is 22, x and then y. So 22 xy. Good. Last but not least, we've got 12x squared plus 4x squared. Again, you've got the same variable, which means you can just go and do now 12 with 4, which is equal to 16, and your variable x squared, 16x squared. That is your answer. Okay, so there we go. That's a bit of an intro to collecting like terms. The next video is going to be looking at some harder variations. Okay, but we'll get on to that in the next video. Okay, thank you for watching.